So in the last lecture, we have started with compounds of sodium, and among the compounds of sodium, we have discussed about sodium oxide, which can be prepared whenever you are reacting sodium in limited amount of oxygen. Then we have discussed about sodium peroxide, and most of its reactions are similar to that of hydrogen peroxide, H2O2. Then we have seen about NaOH, उसका preparation method देखा, and उसमें reactions सारे नहीं देखा हमने. Today we will be seeing further reactions of NaOH. And there are very two important compounds, which are washing soda and baking soda. In this lecture, we will see the preparation methods of them. First, let us quickly revise about some important points about sodium oxide and sodium peroxide. The reaction with water. This reaction is important. Reaction with water, Na2O, any metallic oxide is basic in nature. So whenever I dissolve metallic oxide in water, I'll be forming a base. So Na2O plus water, you are getting NaOH. Okay. If this NaOH is reacted with CO2, it will be converting into Na2CO3. Similarly, we have seen the reaction of Na2O2 with water. Na2O2 को पानी के साथ मिलाया तो you just need to replace this Na positive and you need to replace that by H positive. So you'll be forming H2O2. You are forming NaOH. यहाँ पे केवल NaOH मिला है. In this case, you are forming NaOH along with H2O2. Okay. And whenever you are warming it, if you heat H2O2, it converts into H2 and O2. So if you are having a warm H2O, then you will be forming NaOH plus H2O2. This H2O2 further splits into H2 and O2. So left hand side में भी आपको H2O और right hand side में भी H2O cancel होके you are not seeing any H2O on the product side. So the products are NaOH and O2. Just remember one thing: if I am dissolving Na2O in water, you are getting one product. If you are dissolving peroxide in water, you are getting two products, which is NaOH and H2O2 in cold condition, NaOH plus O2 in hot condition. Similarly, the same reaction can happen with an acid, Na2O2 plus H2SO4. Cold condition में आपको Na2SO4 plus H2O2 मिला. Warm condition पे या hot condition पे ये जो H2O2 है splits into H2 and O2. And आपको एक homework दिया है, the reaction of peroxide with water. Superoxide with water. Superoxide can be formed only with potassium, rubidium, and cesium.
सर आप म्यूट हो गए हो.
It got disconnected. Give me 2 minutes. कहाँ तक सुना आप लोग? डिस्कनेक्ट होने से पहले कहाँ तक सुना?
Reaction of superoxide with water.
Reaction of superoxide with water. Just remember one thing: these dissolution reactions in water, oxide का dissolution in water leading to NaOH, peroxide का dissolution in water leading to O2 plus NaOH or H2O2 and NaOH, superoxide का dissolution in water leading to three products: KOH, H2O2 and O2. You can make a separate sheet of paper जिसमें आप लोग important reactions mark करके जा सकते हो, because throughout the inorganic chemistry there are some reactions which are majorly important. बाकी reactions आप लोग कभी-कभी भूल भी गया चलेगा, but you need to remember some set of reactions. So every time you cannot open the notes and you cannot go through all the reactions. So please mark these three reactions, everyone, very, very important. After the class, take a separate sheet of paper. Everyone, please put your video on. After the class, take a separate sheet of paper. mark these reactions: Na2O का dissolution in water, Na2O2 dissolution in water, and superoxide dissolution in water. Okay, ठीक है. Then we have seen the oxidizing property. Na2O2 has an oxidizing property because it is salt of H2O2. H2O2 is an oxidizing agent, so Na2O2 also acts as oxidizing agent. Okay, H2O2 हमने redox के chapter में पढ़ा है. It can act as oxidizing agent as well as reducing agent, and in either of the cases, the Z factor is always going to be 2. Okay, so H2O2, as it can also act as a reducing agent, whenever you are adding a stronger oxidizing agent when compared to H2O2, it will be acting like reducing agent. So this is the reaction where it is acting like reducing agent. So KMnO4 H2O2 के साथ react or Na2O2 के साथ react होके you are producing O2. You can think of this reaction as a reaction that generates O2. इस particular reaction में O2 liberate हुआ. Is that clear? Okay. And you can remember that this particular preparation method, preparation of oxygen, and it is under the name of oxone. Then we have seen the preparation method of sodium hydroxide. Sodium hydroxide बनाने के लिए we have 2 different cells. One is Nelson cell or diaphragm cell, where you will be using the electrode as platinum. Whenever you are using electrode as platinum and you are doing here electrolysis of aqueous NaCl. If you are doing electrolysis of aqueous NaCl in the solution, you have Na positive ions, you have Cl minus ions, and you have H2O. At cathode, always there is going to be reduction in any electrolysis process. Cathode के पास हमेशा reduction होगा, anode के पास हमेशा oxidation होगा. So cathode पे आपको Na positive ions भी है, water molecules भी है. Na positive has lesser tendency for reduction, hence Na positive won't be accepting an electron and it won't be converting into Na. H2O जो है उसका reduction होके आपको H2 liberate होगा, in the process OH minus भी बन रहा है. So you are having Na positive in the system as well as OH minus, so these both combine to form NaOH, or the solution is becoming more and more basic. At anode, there will be oxidation. The anion that is present at anode is Cl minus. Cl minus undergoes oxidation to form Cl2. So at the end, you are having Na positive, OH minus दोनों combine होकर NaOH मिला, and there is liberation of Cl2. In this particular reaction, there is a drawback in this cell. The drawback is the liberated Cl2 can immediately react with NaOH. So you need to have separation between the NaOH and Cl2. Cl2 is reactive with NaOH and it can even react at cold condition. So Cl2 का reaction यहाँ पे लिखा है, at cold condition it is forming hypochlorite NaClO, and हमने hot condition पे भी reaction देखा. In hot condition, what is the reaction? It forms, what does it form? Cl2 plus hot NaOH. It forms chlorate. Okay, chlorate, NaClO3. This is also an important reaction. You can mark this reaction and the reaction with hot NaOH in a separate paper. Important reaction. So mark that in a separate paper. Okay. So I will suggest all the reactions for you to mark in a separate paper. Please mark all those reactions in a separate paper. Is that clear? Okay. Okay. उसके बाद हमने to overcome this particular problem और एक modification देखा which is called as Kastner-Kellner cell, and Kastner-Kellner cell का और एक दूसरा modification is Solvay-Kellner cell. इनमें cells में construction different रहेगा, but the cathode that is used is mercury. Whenever you are having mercury as the cathode, Na positive के लिए reduction होने के लिए tendency ज़्यादा होगा. So rather than H2O undergoing reduction, Na positive ions will undergo reduction and they convert into Na. The reason is the formed Na is having very high tendency to form an amalgam with Hg. So immediately Na positive Na जैसा बन जाएगा, Na जैसा बनते ही it will react with Hg to form sodium amalgam. Okay. So as a result, you are not preparing NaOH in the cell. You are forming NaHg first. This NaHg, if you remove that and if you dissolve that in water, you will be getting NaOH. So there is no point of, or there is no chance for the contact of Cl2 with the NaOH. Is that clear? Okay. What you need to remember is you need to remember the names of these. NaOH preparation के लिए क्या-क्या use करते हैं. You can either use Nelson cell or diaphragm cell, or you can use, the better way is to use Kastner-Kellner cell or Solvay-Kellner cell. Is that clear? Okay. NaOH, it is highly deliquescent. What is meant by deliquescent? Anything that absorbs moisture. It is called as deliquescent, or it is also called as hygroscopic. NaOH is deliquescent or hygroscopic. As a result, it absorbs most of the moisture and it converts into liquid. It is highly soluble in water. We know that NaOH is a strong base. It is soluble in water. As it is basic in nature, it is corrosive, and it is very less soluble in alcohol. ये जो less solubility in alcohol, इसका reason जो है, we will understand more and more in detail in organic. We will soon start organic. From Feb we will be starting organic. So वहाँ पे और समझेंगे. Okay, ठीक है. It absorbs CO2. Obvious, CO2. It is non-metallic oxide. Non-metallic oxides are acidic in nature. This is a base. Acid plus base will give you salt and water. If you are passing excess amount of CO2, Na2CO3 with water, and if you are passing excess amount of CO2, the formed carbonate converts into bicarbonate. This is also an important reaction. The formed carbonate converts into bicarbonate. इस reaction में exactly कैसे होता है? ये जो CO2 है ना, everyone understand this. If you know more and more details, then you can remember them easily. H2O CO2 के साथ react होके it converts into H2CO3. Okay. अभी ये जो Na2CO3 जो है, that Na2CO3 will be reacting with H2CO3. क्या होगा? इसके अंदर से एक H positive हटा दो. If I am removing H positive, this converts into HCO3 minus. Give that H positive to here. This also converts into HCO3 minus. यहाँ से एक Na positive इसको दे दो. Both of them are converting into NaHCO3. Understood? H2CO3 is an acid. यहाँ पे CO3 2 minus है आपके पास. Okay, I think this is a separate page. What is happening? CO3 2 minus जो है वो H2CO3 के साथ react होके it is converting into HCO3 2 minus. Remember, यहाँ पे H2CO3 के अंदर से H positive हटा दिया, ये HCO3 minus में convert हो रहा है, ये भी HCO3 minus में convert हो रहा है. So you are getting 2 molecules of HCO3 minus. Hence the carbonate is converting into bicarbonate. Understood everyone? Okay. ठीक है. So H2CO3 is called as carbonic acid. Next step. We have seen the reactions of NaOH. Common reactions can be NaOH being a base, it will be reacting with acid. So all acid-base reactions, which will lead to the formation of salt and water. So these are obvious reactions. NaOH being a base, it can react with acids. Non-metallic oxides are basic in nature. And how to write the products? इनके साथ products कैसे लिखना है? CO2 को जब पानी में मिलाता हूँ, H2CO3 मिलेगा. CO2 with water. Simply add H2O to CO2. What will you get? H2CO3. Simply add H2O to SO2. You will be getting H2SO3. You can also write another reaction. SO3 plus H2O you will get H2SO4. H2SO4 plus NaOH you will be getting Na2SO4. Okay. So यहाँ पे आप लोग और एक reaction भी लिख सकते हैं, which is reaction with SO3. SO2 के साथ जैसे reaction करवाया, SO3 के साथ भी करवा सकते हो. Okay. The product in this case is Na2SO3. In SO3 it will be Na2SO4. Any doubt? अभी ये जो NO2 है, we will understand again in the chapter of P block about NO2. NO2 is called as mixed anhydride. Mixed anhydride मतलब इसको जब भी पानी में मिलाता हूँ, you will be getting two different types of acids. If I take NO2 here, don't directly dissolve this in water. NO2 जो है, you can remember this in a different way. If I draw the structure of NO2, NO, O, नाइट्रोजन और ऑक्सीजन के बीच में डबल बॉन्ड बनाओ. नाइट्रोजन का outermost इलेक्ट्रॉन्स कितने हैं? 5 इलेक्ट्रॉन्स. ओके. उन 5 में से 2 इलेक्ट्रॉन्स बॉन्डिंग में गया. यू आर लेफ्ट विथ 3 इलेक्ट्रॉन्स. ये जो 2 इलेक्ट्रॉन्स है, इसको कोऑर्डिनेट बॉन्ड में इसको दे दो. ऑक्सीजन का भी ऑक्टेट, दूसरे ऑक्सीजन का भी ऑक्टेट कंप्लीट हो जाएगा. सो यू आर लेफ्ट विथ 1 इलेक्ट्रॉन. If you are left with 1 electron, it will be called as paramagnetic. What you can do is NO2 जो है, it can exist as a dimer डाइमर मतलब 2 यूनिट्स मिलके, यहाँ पे एक इलेक्ट्रॉन, वैसे यहाँ पे और एक इलेक्ट्रॉन, double bond O. It will be existing as a dimer in order to have a bond, the bond between this unpaired electron. So NO2 जो है in general dimer जैसे exist होगा. So if you want to form acids out of NO2, first convert that into N2O4 because it is existing as a dimer. इस N2O4 को पानी में मिलाओ, तब क्या मिलेगा? H2N2O5. H2N2O5 is combination of HNO2 plus HNO3. Is that clear? So NO2, whenever I dissolve that in water, I will be getting HNO2 plus HNO3, combination of nitrous acid and nitric acid. Is that clear? Okay. So HNO2 के साथ it will be forming NaNO2, HNO3 के साथ it will be forming NaNO3. यहाँ तक देखा हमने. Next set of reactions. ये reactions पे देख लिया क्या हमने? We have seen these reactions as well, right? Everyone, please confirm. Yeah, ये reactions भी देख लिया. With amphoteric oxides. Very, very important. Please remember these elements. These will form amphoteric oxides. Not only in S block, we will be encountering them in next chapter of P block. उसके बाद P block 12th में भी है, उसमें भी आता है. So remember these: aluminium, zinc, tin, or lead. They will form amphoteric oxides. What is meant by an amphoteric oxide? One which can react with acid as well as base. If it is reacting with acid, Al2O3 acid के साथ react किया तो AlCl3 बन जाएगा. HCl के साथ, suppose HCl के साथ react किया तो ZNO HCl के साथ react किया तो you will be forming ZnCl2. SNO HCl के साथ react किया तो SnCl2. SnO2 HCl के साथ react किया तो SnCl4. PbO with HCl PbCl2. PbO2 with HCl PbCl4. Those are the reactions with acids. We can write a reaction with base. Whenever you are reacting these with base, you will be forming some compounds called aluminate, zincate. This is stannous, stannite. Okay. यहाँ पे stannate, +4 वाला stannate, plumbite, plumbate. Is that clear? Okay. You need to know how to get the formulas of them as well. Zn +2 oxidation state है, so Na और O को you need to arrange so that you need to balance the charge. Na2 Zn O2 से ही आपको +2 oxidation state सब कुछ balance होगा. Okay. Is that clear? NaAlO2, Al +3 है, ऑक्सीजन का ऑलरेडी यहाँ पे -4 है, so इसलिए NaAlO2. I hope that's clear. Okay. Other than this, some other elements which are metalloids: boron, silicon, germanium, arsenic, antimony, tellurium, and polonium. Okay. So ये भी याद रखो. These are metalloids. The मतलब the one which can react with acids as well as bases. Okay. उसके बाद हम कुछ reactions देखा है with non-metals. NaOH with boron. Again, this being a metalloid, जैसे इन amphoteric oxides के साथ product मिला है aluminate, stannate, वैसा ही यहाँ पे भी borate मिलेगा Na3BO3. Na3BO3 जो भी बना है, you can इसका corresponding acid क्या रहेगा? H3BO3. H3BO3 बनता है, वो NaOH के साथ react करके it is forming Na3BO3. H3BO3 is also called as boric acid. Okay, H3BO3. This is borate, sodium borate. With silicon, it will be forming silicate, sodium silicate. This reaction is very important. NaOH with white phosphorus and NaOH आपको same NaOH दूसरा भी दिया क्या reaction? नहीं दिया है, white phosphorus के साथ ही दिया है. We will see another reaction, the reaction of NaOH with red phosphorus in P block. So white phosphorus वाला reaction यहाँ पे याद रख लो. Okay, and it is a disproportionation reaction. It converts into sodium hypophosphite as well as phosphine. H3PO4 is called as phosphoric acid. H3PO3 is called as phosphorus acid. एक oxygen कम हुआ तो it will be called it can be called as hypophosphorus acid. Hypophosphorus acid is monobasic acid. So यहाँ पे पानी में मिलते ही P4 पानी में मिलते ही आपको H3PO2 आएगा, which is hypophosphorus acid. That on reaction with NaOH, as it is able to give one H positive, it can react with one Na positive or one OH minus, leading to the formation of NaH2PO2. Any doubt in here? you can add this reaction also in your separate page. Add this reaction, mark this reaction also in a separate page. Okay, यहाँ पे these reactions you need to remember them. So if you want to add these reactions, you can also add these reactions. Very, very important. You may add these reactions as well. Next, add these two reactions. The reaction of NaOH with Cl2 in cold condition leading to the formation of hypohalite. In hot condition leading to the formation of halate. Chlorine के साथ hypochlorite. Hot condition पे chlorate. Okay. ठीक है. Sulfur with NaOH. This is also an important reaction. You will be forming hypo. Sodium thiosulfate, which is also an good oxidizing agent. Hypo. Okay. Ammonium salts. Ammonium मतलब NH4 positive. As it is NH4 positive, it can give H positive. If it is giving H positive, this is a base. This is an acid. Acid-base reaction. Okay, आपको H2O, or there is liberation of NH3 gas. Is that clear? Any ammonium salt with NaOH will always liberate NH3 gas, ammonia gas. Okay. यहाँ पे आपको और एक extra information दे रहा हूँ, which can be useful in further chapters. Whenever there is liberation of NH3 gas, in order to identify if NH3 gas is getting liberated or not, what you can do is you can pass that NH3 through a solution of copper sulfate. Copper sulfate solution का color जो रहता है, it is light blue. Okay. Whenever you pass NH3 through copper sulfate solution, it converts into deep blue. If NH3 is passed through a solution of copper sulfate, it converts into deep blue. Okay. This can be used as a test for NH3. NH3 liberate हुआ कि नहीं. Pass that NH3 through CuSO4 solution, which is initially having a light blue color, converts into deep blue. This is also an important observation or important test which can be useful in your entrance exams in future. Okay. अभी के लिए mark करके रखो. You can also add this particular part in the separate sheet. Okay. By the end of entire inorganic, we will be maximum making 3 A4 pages. Okay. उतना भी नहीं बनेंगे. 2 A4 pages जितना बनेंगे उतना काफी है. Just before exam, if you revise all those things, that is more than sufficient. Okay. ठीक है. Next, action on salts. I think यहाँ से आपको करना है action on salts. Whenever you are adding NaOH to salt, there are some salts which are going to form insoluble hydroxides. There are some salts which are going to initially form insoluble hydroxide, but upon addition of excess of NaOH, that particular precipitate is going to dissolve. Okay. Some salts which will be leading to the formation of insoluble hydroxides, which will be having some certain colors. Upon addition of excess of NaOH, that particular precipitate may not dissolve. There are some set of salts which will be forming initially insoluble hydroxide, but upon addition of excess of NaOH, that is going to dissolve. And there are some salts which are going to give unstable hydroxides. Unstable hydroxide matlab if that formed hydroxide will convert into some other product. Okay. So dekhte hai how to remember insoluble hydroxides. Fe, Cr, Ni, Mn, Cu. Iron, chromium, nickel, manganese, copper. You can remember this as Fikar Nai Manko. Everyone, please put your video on. I hope I'm audible. Yeah. How to remember this? You can remember this as Fikar Nai Manko. Okay. You can add this. You can add this particular point because questions may they will be using some statements like there is a metal which forms a salt with so and so, which forms an insoluble precipitate with sodium hydroxide. So these are the set of things you need to think about. Is that clear? Okay. Nickel hydroxide. Okay. Ferrous hydroxide, ferric hydroxide. With Mn, you will be forming manganese hydroxide, chromium hydroxide, and copper hydroxide. अभी यहाँ पे कलर्स आपको FeOH थ्राइस, MnOH थ्राइस, CrOH थ्राइस और COH twice इनके लिए दिया हूँ कलर्स. This is red PPT, this is buff colored, this is chromium has green colored PPT and copper has blue colored PPT. Okay. Whenever you have chromium PPTs, most of them are green colored. So ये तो आप लोग फ्यूचर में भी ग्रीन कलर्स इनका देखेंगे. कॉपर का इन जनरल ब्लू कलर रहता है. So you can remember these two colors separately. With iron, it is red PPT. With manganese, it is buff colored PPT. Is that clear? You need to remember these things. And the insoluble hydroxide, which is soluble in excess of NaOH. This is very easy because you will be forming amphoteric hydroxides, zinc, lead, aluminum or tin. Just abhi हमने पढ़ा है, all these oxides are amphoteric or their hydroxides will also be amphoteric. Amphoteric matlab they can react with acid as well as base. So once you form a hydroxide, these salts, once they are forming hydroxides, they're able to dissolve in excess of NaOH because of the reaction. Hydroxide is acidic as well as basic. NaOH add kiya to it will be acting like an acid. So uske sath react karke it will be forming some soluble salts. Na2ZnO2 with sodium zincate, aluminate, okay, stannite, plumbate. Okay, is it clear? Plumbite, not plumbate, plumbite. Okay, I hope this is clear. Unstable hydroxides, AgOH as well as HgOH twice. ये जो Ag और Hg, if you observe, these come in the at the end of individual the D block series. Okay, D block में left to right, the Z star increases. If the Z star increases, what will happen to the covalent character? The covalent character also increases. So AgOH और HgOH twice में आपको significant covalent character रहेगा. इसके वजह से they are thermally unstable. Okay, they are unstable and they convert into Ag2O, which is a brown PPT, and HgO, which is an yellow PPT. Is that clear? Okay, let's go to the next part. So please remember these things. Important है ये. इनमें पहले दो तो और ज्यादा important है. Insoluble hydroxide, which is also insoluble in excess of NaOH. Initially formation of insoluble hydroxide, which is soluble in excess of NaOH. These two sets are important. यहाँ पे दो ही reactions है, you can easily remember them. Okay. Next, users कुछ users लिखा है. Among these users, remember this use. It is used in the purification of bauxite ore. When we do metallurgy or even in P block during extraction of aluminium, we will understand how it is exactly used in the purification of bauxite. Okay. So remember this. NaOH is used in the purification of bauxite. अभी आप लोग याद किया तो बाद में जब उस चैप्टर में पढ़ेंगे, then you can immediately recollect. Next, sodium carbonate or washing soda. It is very important compound. Nearly 30 million tons per year is manufactured. So it is highly important. It is of high industrial use. Washing soda, also called as sodium carbonate, Na2CO3 dot 10H2O. It is a decahydrate. Okay, Na2CO3 dot 10H2O. पहले preparation method देखते हैं. If you understand the preparation method of sodium carbonate, sodium bicarbonate का भी preparation method हो जाएगा. Everyone, please put your video on. If you understand the preparation method of carbonate, bicarbonate, which is baking soda, उसका भी हो जाएगा because both of them is almost same. Apart from one step, all other steps are same. Okay. Ammonia solvay soda process, where the raw materials used are common salt. What is common salt? Nothing but NaCl. Everyone, please put your video on. Then you have ammonia, which is NH3. Then you have limestone. Limestone is CaCO3. Okay. In group 2, we have understanding of CaCO3. Uska preparation method is sub hai reactions. So it is an important compound. Common name is limestone, CaCO3. Okay. Let us see what happens in the reaction. In the reaction, what we do is we take saturated solution of NH3. Saturated solution of NH3 matlab you will be dissolving NH3 in water, and in the same water you will be adding NaCl. Okay, so you will be taking saturated solution of NH3 which also has NaCl inside it. Is that clear? Okay, ठीक है. Through that particular saturated solution of NH3 which has NaCl in it, we will be passing CO2. यहाँ पे देखना, in the water, in the solution H2O के अंदर आपके पास क्या क्या है? You have NaCl, you have NH3, both of them are dissolved in H2O. Okay, now through this what you do is you pass CO2. ये जो CO2 है, CO2 is non-metallic oxide. If it is non-metallic oxide, it is acidic. If it is acidic, it will be reacting with that part which is basic. So NaCl जो है वो salt है. NH3 जो है, it can act as base. Ammonia can act as base. So what will happen is that NH3, यहाँ पे reaction लिखा है नीचे आपको. This NH3 is going to react with CO2 to form NH4HCO3, ammonium bicarbonate. Okay, यहाँ पे आप लोग you can write H2O और CO2 इन दोनों के बीच में reaction होके क्या बनता है? Always H2O whenever or CO2 whenever it is dissolved in water, you will form H2CO3. Okay, so ये जो H2CO3 है, it is reacting with NH3. NH3 is a base. I can also say it is a Lewis base. What is meant by Lewis base? One which accepts or one which donates lone pair of electrons. Accepts है, one which donates lone pair of electrons. So यहाँ पे lone pair है, H2CO3 के अंदर से आपको क्या आएगा? H positive आएगा. So this H positive, if it is reacted with this, what will you get? You will be getting NH4 positive. ये दोनों के बीच में reaction okay, you will be forming NH4 positive. इसके अंदर से H positive हटा दिया तो what is the component that is left? You will be left with bicarbonate HCO3 minus. So A HCO3 minus, A NH4 positive. इन दोनों को combine कर लो. You will be getting ammonium bicarbonate. Is that clear? The reaction is also obvious. Ammonia, whenever it is reacting with CO2 in presence of water, H2O or CO2 इन दोनों के बीच में reaction होके, you will be forming H2CO3, which is an acid. NH3 is a base. So इन दोनों के बीच में acid base reaction होके आपको एक salt बना, ammonium bicarbonate. Is that clear? This ammonium bicarbonate then reacts with NaCl. Here you are having exchange of ions. Na positive is substituting this NH4 positive and it is converting into NaHCO3. Or else Na positive is reacting with HCO3 minus to form NaHCO3. If it is soluble, everyone understand this. Ammonium bicarbonate जो है, it is soluble. मतलब in the water it exists as NH4 positive and HCO3 minus. NaCl is soluble. In water it exists as Na positive and Cl minus. But ये जो NaHCO3 जो है, it is insoluble. It is very slightly soluble. Being slightly soluble, Na positive HCO3 minus के साथ combine होके, it is immediately converted into precipitate. Okay, ammonium bicarbonate is soluble, but sodium bicarbonate is insoluble. Okay, or it is slightly soluble because of its very less soluble nature. It is extracted as a precipitate. Okay. And इस reaction में we can never form potassium bicarbonate. मतलब rather than adding NaCl, if anyone is thinking of adding KCl add कर रहे हैं, तब क्या मिलेगा? KHCO3 मिलेगा. KHCO3 जो है, it is more soluble. If it is soluble, again I cannot separate that bicarbonate. I need to add only NaCl because HCO3 is insoluble or it is very less soluble. As a result, I am able to separate that bicarbonate from the solution. Is that clear? This is one of the important competitive questions. They will ask, why do we not prefer to add KCl? Why do we add NaCl in ammonia soda solvay process or solvay ammonia soda process? What is the reason for that? If you are getting KHCO3, potassium bicarbonate is more soluble. As a result, the bicarbonate may not be extracted from the solution. Is that clear? Okay, that's an important question. यहाँ पे लिखा है this particular point, K2CO3 cannot be prepared as KHCO3 is soluble in water. So यहाँ पे हमको bicarbonate मिला है. Once you get the bicarbonate, heating of any bicarbonate will lead to formation of carbonate. So एक बार bicarbonate आ गया तो आपको carbonate मिल जाएगा. This heating process is called as calcination. This heating process is called as calcination. Okay. So यहाँ तक separation of NaHCO3. I can say that as the preparation method for. I can say that as the preparation method for baking soda. Baking soda is sodium bicarbonate. Washing soda is sodium carbonate. So यहाँ तक आप लोग छोड़ दिया तो it is nothing but the preparation method of baking soda. इसका further heat किया तो you will be forming washing soda. Is that clear? So for the formation of baking soda or for the formation of washing soda, you can use Solvay ammonia soda process. और else दोनों में देखो सोडा है ना, baking soda as well as washing soda, दोनों में सोडा है. So Solvay ammonia soda process is used for preparation of both. Is that clear? Everyone in the lecture? Everyone concentrating?
Yes, sir.
Okay. One more very, very important point. In the end, okay, chemistry में there are a lot of chapters which are highly logical, like physical chemistry chapters. बाद में organic पढ़ेंगे. That is also highly logical chapter. Okay. While studying those chapters, you may feel okay, you are understanding a lot of new things. Okay, you are able to apply some new things. Engineering के लिए जो भी चाहिए वैसा feel आएगा. But at the end, आपको final exam में inorganic से भी कुछ questions रहेंगे. Okay, and you may get around out of 25 questions. अभी आजकल 30 questions दे रहे हैं. 30 questions में you may get around 10 questions. और 8 to 10 questions. 8 questions आपको inorganic से आएगा. And those questions, मानो या ना मानो, वही क्रैक करना ज्यादा इजी होता है. Okay. बाकी सब chapters जो है, you may like those chapters more and more, but the questions from them can be challenging at times. But inorganic questions जो है, if you remember some specific set of equations, some specific set of preparations, some specific set of compounds और उनके reactions, उनसे ही questions आता है हमेशा. The only difficulty is remembering them. But immediately you look at the question, you can get the answer, you can mark the answer. You can save a lot of time in inorganic chemistry. वही टाइम आप लोग मैथ्स में और फिजिक्स में ज्यादा इन्वेस्ट करके you can score good marks. Okay, so don't neglect inorganic. Whenever we are having an inorganic chapter, try to solve more and more questions. आप लोग जयसवाल बुक लिया ही है ना सब लोग, so जयसवाल book भी open करके you can solve questions, and in that जयसवाल book some of the questions may be related to the other chapters. मतलब inorganic में भी आपको combination of chapters से question आ सकता है. So if you are unable to get that question as of now, it's fine. But जो भी इस chapter का questions है, हमारे notes के हिसाब से जो भी questions है, वो सब बनना चाहिए. If you are unable to get any answer, please, you can send those questions. You can take a photo of that particular question. You can send that question. You can discuss. Is that clear? Okay. So inorganic का lecture हो जाने के बाद, again read the notes and solve some questions. Then you will understand कौन सा equation ज़्यादा याद रखना है. Is that clear? Okay, ठीक है. Continue करते हैं, आगे continue करते हैं. Okay. यहाँ पे let us individually understand what is the purpose of this common salt. Common salt किसके लिए? Once you are forming ammonium bicarbonate, NaCl is reacting with that to form sodium bicarbonate. What is the purpose of NH3? From NH3 only, you are forming that ammonium bicarbonate. What is the purpose of CaCO3? CaCO3 के अंदर से ही हम CO2 generate करेंगे. If you have CaCO3, First, you will be heating it to convert into CaO and CO2. This CO2 is passed through the saturated solution of NH3. Then you will be getting ammonium bicarbonate. Then it will be reacting with NaCl to form sodium bicarbonate. Is that clear? Okay. We can also use this CaO also for the regeneration of NH3. देखो यहाँ पे CaO, quicklime. CaO is called as quicklime. CaCO3 is called as, very, very important. Remember these names, common names. Calcium oxide is called as quicklime. CaCO3 is called as limestone. Whenever it is dissolved in water, you will be getting a compound called, this can either be called as slaked lime. This can be called as milk of lime. Okay, slaked lime or milk of lime. ये जो CaOH twice calcium hydroxide जो है, it will be reacting with NH4Cl. यहाँ पे मिला है आपको NH4Cl. NH4Cl के साथ react होके NH4 positive is an acid, CaOH twice it is a base, acid plus base. So H positive इससे हटा दो, you will be gaining NH3, and you are forming CaCl2. CaCl2 is one of the important byproducts obtained in the process. So this is also an important point in the ammonia solvate soda process. You are getting the CaCl2, an important byproduct. Okay. Okay. So what are the individual steps? Saturation of brine. Brine is nothing but NaCl. Saturation of NaCl solution is called as brine. With ammonia, then you are having carbonation. मतलब इसके through CO2 pass कर रहे, which is leading to the formation of ammonium bicarbonate, further leading to the formation of sodium bicarbonate. सोडियम बाइकार्बोनेट बीइंग प्रेसिपिटेट, आपको उसको फिल्ट्रेशन करना पड़ेगा, वो प्रेसिपिटेट को हटा दिया, उसके बाद उसी सॉल्यूशन में आपका NH4Cl है. NH4Cl if it is treated with CaOH twice which is formed from calcium oxide, you will be getting NH3. Okay, and ये जो precipitate मिला है, if you do calcination मतलब if you are heating it, it converts into sodium carbonate. आगे बढ़ो. Okay. Properties, it is white crystalline solid. Washing soda is white crystalline solid which exists as decahydrate. It exhibits a property called efflorescence. Okay, we have different properties. Deliquescence. Okay, efflorescence. We also have a property called fluorescence. Fluorescence matlab which produces sparks or which produces light whenever any light is instant on it. Okay, which glows whenever a light is instant on it. It is called as fluorescence. This is called as efflorescence. Efflorescence matlab whenever you leave that particular substance in air, it will be losing its water of crystallization. Okay, this particular 10H2O, it is called as water of crystallization. If you are leaving that washing soda to air, some of the water of the crystallization will be evaporated. As a result, if some water molecules are removed, what will happen to the weight? The weight of the substance is going to decrease. Okay, so when exposed to air, it loses water. The decahydrate is converting into monohydrate. Hence, washing soda loses weight on exposure to air. Okay, heating effect. This reaction is also important. They will directly ask the temperature Na2CO3.10H2O 375 पे heat करने से आपको monohydrate मिल रहे हैं. If you are heating it above 375 Kelvin, you are getting something called soda ash. Okay, so they will ask Na2CO3.10H2O. This reaction is important. If it is heated above 375 Kelvin, it will lead to a formation of a compound called soda ash. Okay, Na2CO3. It is whenever it is dissolved in water, it forms a solution which is alkaline. The resulting solution is alkaline. How to remember this? ऐसा याद रखो, everyone. Na2CO3 is formed from H2CO3 and NaOH. So इसको पानी में मिलाने से आपको वही वापस मिल रहे हैं H2CO3 और NaOH. Reversible reaction है, मतलब H2CO3 plus NaOH react होके आपको Na2CO3 मिलेगा, और वही Na2CO3 को excess of water में डाल दिया तो आपको H2CO3 NaOH मिलेगा. H2CO3 is a weak acid. Okay, carbonic acid is weak acid. H2CO3 is nothing but soda water. if you are having water, उसके अंदर CO2 कार्बन डाइऑक्साइड मिला लिया तो whatever the soda you drink, it is nothing but carbonic acid water. It is a weak acid. If it is a strong acid, हम उसको पिएंगे नहीं ना. Okay, H2CO3 is a weak acid. NaOH is a strong base. So weak acid, strong base, which is more dominant. Base is dominant because it is strong. So the resulting solution is going to be alkaline. Okay, if any salt is made up of a strong acid and weak base, acid is dominant, hence the resulting solution is, in that case, will be acidic. Okay, ऐसा याद रखो everyone. Okay, weak acid plus strong base, hence the resulting solution is alkaline. If something is strong acid and weak base, the resulting solution is going to be acidic. Okay, okay, good. Na2CO3 upon reaction with H2O and CO2, मतलब Na2CO3 को पानी में मिलाने के बाद CO2 ऐड किया तो it will convert into bicarbonate. And this is also general reaction for any carbonate. कोई भी carbonate को CO2 के थ्रू पास किया तो you will be forming bicarbonate. I think यही पे हमने डिस्कस भी किया है, कहीं तो डिस्कस किया है अभी अभी. ओके, ठीक है. यहाँ पे हो क्या होगा, H2O और CO2 ये दोनों के बीच में रिएक्शन होके व्हाट यू विल गेट, H2CO3. H2CO3 के अंदर से H पॉजिटिव इसको दे दो CO3 2 माइनस को. Na2CO3 में आपके पास क्या है, CO3 2 minus है. So transfer one H positive here. So you will be getting this as HCO3 minus. This also converts into HCO3 minus. So you are having bicarbonate. Okay. Any carbonate upon reaction with CO2 in the presence of water. Okay. Upon reaction of with CO2 in the presence of water, it will always form bicarbonate. Is that clear? Okay. Next. It is used in the manufacture of glass, caustic soda. Okay. So caustic soda is nothing but NaOH. क्योंकि Na2CO3 को पानी में मिला लिया तो आपको NaOH मिल रहा है ना. Okay. You can remember out of these things. This is important. It is used in laundries and in softening of water. This is an important use. It is used in laboratory in the form of fusion mixture. This is a laboratory reagent which is used in some reactions. This is called as fusion mixture. You will directly get the question, which of the following is called as fusion mixture? Na2CO3 plus K2CO3. It is called as fusion mixture. Okay. What is chili saltpeter? What is chili saltpeter?
NaNO3.
NaNO3. What is Indian saltpeter?
NO3.
NaNO3. Good. वो भी एक याद रखना. Okay. Chili saltpeter, Indian saltpeter. ठीक है. Okay. Let's go to next, sodium bicarbonate. This is about sodium carbonate. Let's go to bicarbonate. Bicarbonate का preparation method में क्या करना है? It is also solve ammonia soda process where you will be dissolving NH3 in brine solution. Brine solution is nothing but NaCl in water. That NH3 dissolved in H2O. Through that, if I am passing CO2, how to get that CO2? By heating CaCO3, limestone. Okay. So CO2 को pass किया तो you will be forming ammonium bicarbonate. Ammonium bicarbonate is soluble, but if it reacts with Na positive, it will be forming sodium bicarbonate, which is insoluble, so it can be removed. NaHCO3 आ गया तो आपको मिल गया. That is the preparation method of baking soda. Is that clear? How to regain or regenerate that NH3? CaO को पानी में मिला लो. It is an important reaction again. If I am putting CaO in water, I will be converting that into CaOH twice. CaOH twice जो है, it is also called as, what is CaOH twice called as? यहाँ पे लिखा है ना, slaked lime, or it is also called as milk of lime. Okay, ये याद नहीं रहेगा, बाद continuous revision से आपको याद हो जाएगा. Okay, ठीक है. So yeah, कहाँ पे? Yeah, once you get that COH twice, NH4Cl जो है, it will be reacting with COH twice to degenerate NH3. Is that clear? All the steps are similar to that of preparation of an sodium carbonate. Okay, washing soda. The only difference is once you get this NaCO3, don't heat it. If you are heating it, it will convert into carbonate. Is that clear? Okay. ठीक है. Next, it is called as baking soda. The reason is whenever you heat it, it decomposes to generate CO2 because NaHCO3 upon heating, it converts into Na2CO3. Okay, यहाँ पे लिखा है heating reaction Na2CO3 plus CO2. So because of liberation of CO2, it leaves holes in cakes and makes them fluffy and light. Okay, NaCO3 whenever heated, it converts into CO2 and H2O. Or the CO2 it escapes out, leaving some holes. As it is escaping out, it becomes light as well. Okay, it becomes light and fluffy, hence it is called as baking soda. Okay, I hope this is clear. NaCO3 upon dissolution in water, Na2CO3 को पानी में मिलाने से क्या आया हमको? NaOH plus H2CO3 सेम है. Na2CO3 plus water, NaOH plus H2CO3, NaHCO3 plus water. यहाँ पे H पॉजिटिव इसके साथ चला जाएगा, H2CO3 हो जाएगा, OH माइनस इसके साथ चला जाएगा and NaOH बन जाएगा. This is also formed from weak acid and a strong base, hence the overall solution is alkaline. Is that clear? Any doubt, anyone? Any doubt, anyone? Okay. NaCO3. Everyone, please put your video on. NaCO3, whenever it is heated, it converts into carbonate plus CO2 and H2O. NaCO3 plus HCl. HCl H positive देगा, वही H positive HCO3 minus consume करेगा. It forms H2CO3 plus NaCl. H2CO3 being unstable. HCl, whenever you are adding an acid, the system will be having some amount of energy. So that energy is sufficient and H2CO3 immediately breaks into CO2 and H2O. Okay. So यहाँ पे H2CO3 मिला है, that is converting into CO2 and H2O. NaCO3 plus NaOH. OH minus से HCO3 minus can also act as everyone. HCO3 minus जो है, it can give H positive minus H positive. If it is giving H positive, it converts into CO3 2 minus. It can also accept H positive. अगर वो H positive accept किया तो it converts into H2CO3. So the one which is giving H positive, उसके साथ H positive accept कर लेगा. The one which is accepting H positive, OH minus H positive ले लेगा ना, उसके साथ the H positive will be given out. So इस केस में आपको NaCl plus H2CO3 मिला, इस केस में आपको Na2CO3 plus H2O मिला. Understood? It is, or else it is acting like an acid as well as base. HCl के साथ वो base जैसा act किया, NaOH के साथ acid जैसा act किया. Is that clear? Okay. It is used as antiseptic. It is also used in fire extinguishers. This is an important use. Fire extinguishers. Okay. Sodium bicarbonate is used in fire extinguishers. Very, very important. Next, sodium chloride. The source for sodium chloride preparation is either seawater or salt lakes. Okay. And it is not highly hygroscopic. It is considered as hygroscopic, but actually में आपको already कहा मैंने, LiCl is hygroscopic. Once again, I am revising it. LiCl जो है वो hygroscopic है. It converts into LiCl dot 2H2O. Only lithium chloride is hygroscopic. Sodium chloride, potassium chloride, ये सब hygroscopic नहीं है. यहाँ पे मैंने hygroscopic करके इसलिए लिखा, NaCl has an impurity of MgCl2 or CaCl2 because of presence of magnesium and calcium chlorides, it is seen as hygroscopic. But actually, if you have pure NaCl, is it hygroscopic? No, it can never absorb moisture. MgCl2 hygroscopic, CaCl2 hygroscopic. Okay? Both of them are present as impurities in NaCl. Hence, NaCl is also seen as hygroscopic. Is that clear? Okay. This is an important reaction. NaCl reaction with AgNO3. आपको AgCl बनेगा, which is white PPT. Okay. Similarly, if you have NaBr reacting with AgNO3, तब आपको AgBr precipitate मिलेगा. अगर NaI रिएक्ट किया तो आपको AgI precipitate मिलेगा. AgBr जो है, it is pale yellow. You need to remember all these colors and these PPTs. जो important है वही आपको मैं देता हूँ in general. जो unnecessary information है, apart from notes, बाकी सब information याद रखने की जरूरत नहीं है. AgI, this is yellow PPT. This information is important. So इसलिए मार्क किया है यहाँ पे. So याद रखना. AgCl is white PPT, AgBr is pale yellow PPT, AgI is yellow PPT. Okay. Cl minus Ag positive दोनों combine होके AgCl बन रहे. AgCl is also sparingly soluble. मतलब वो soluble नहीं होगा because इसका covalent character ज़्यादा है. If it is more and more ionic, then it can be soluble because of the greater covalent character of AgCl, AgBr, AgI. Those are precipitates. Is that clear? Okay, next. Sodium sulfate, which is also called as salt cake. Sodium sulfate, also called as salt cake. Preparation method, NaCl plus H2SO4. You will be getting Na2SO4 plus HCl. Okay. NaCl plus NaHSO4. These are obvious reactions. You will be again getting Na2SO4 plus HCl. How to get that NaHSO4? NaNO3, when it reacts with H2SO4, it forms NaHSO4 plus HNO3. ये reaction इसलिए possible होता है. HNO3 is a weaker acid when compared to H2SO4. Okay. जब भी हम कुछ reaction करेंगे, always the reaction will go from a strong direction to a weak direction. You cannot have the other way around. HNO3 को जब NaHSO4 को डाल देंगे, H2SO4 and NaNO3 नहीं मिलता है. Okay, मिला भी है, the amount of that particular reaction is going to be very less. This reaction will be predominantly in forward direction. Okay, every time a strong substance is going to react with some other substance, strong substance, to form a weaker substance, weaker compound. So H2SO4 यहाँ पे HNO3 मिल रहे हैं. HNO3 is a weak acid when compared to H2SO4. As such, HNO3 strong acid है, but comparison यहाँ पे H2SO4 is a stronger acid when compared to HNO3. इसलिए react होके HNO3 में convert हो रहे हैं. Is that clear? Okay. This is again ठीक है, ठीक ठाक important है, not so important. Different temperature conditions पे the amount of water present inside it. At temperature less than 32, 10H2O form में exist हो रहे. Less than 12 हो गया तो it is converting into a heptahydrate 7H2O. Greater than 32, it is converting into anhydrous form. You may remember these things, a temperature conditions. Different temperature conditions में the amount of water which is present inside Na2SO4 is different. Okay. Again, as the water content is changing, it is also called as efflorescent, which can lose water. Okay, upon action of dry air. Na2SO4.10H2O जो है, it is converting into Na2SO4, so it is efflorescent. Some reactions, lead के साथ, it forms lead sulfate, which is precipitate. Remember, lead sulfate is a PPT. Okay, lead sulfate, Na2SO4 with H2SO4, it converts into, यहाँ पे देखा हमने already. Okay, it converts into H positive इसको दे दो, it converts into NaHSO4. With carbon, it is converting into carbon monoxide. Okay, with carbon, so this can be used as preparation method of carbon monoxide. Not so important, so it's fine. Just remember it is efflorescent. Okay, is it clear? Okay, the end of group 1. So you can attempt all the questions of group 1 from Jaiswal book. Okay, you can attempt most of the questions. आपको टेस्ट पेपर में भी जो भी हमने पढ़ा है उन्हीं के ऊपर क्वेश्चंस दिया है. Okay, we will have discussion of the test paper once we complete this chapter. Complete हो जाने दो, then we will be solving some set of questions as well as test paper discussion कर लेते हैं इस week में. Okay. Next. Alkaline earth metals. Let's start with alkaline earth metals. In alkali metals, first we discussed about general properties, which is ionization energy, densities, colors in flame test. उनके बारे में discussion करके then we understood about some important compounds of alkali metals. इसमें भी वैसा ही करेंगे. First we will discuss about the general properties, then we will go to some important compounds of alkaline earth metals. Okay. Alkaline earth metals, I hope everyone of you know all the members of it. Beryllium, magnesium, calcium, strontium, barium, radium, out of which radium is radioactive. So इसके बारे में in general discussion नहीं करेंगे. General properties में we will be understanding the variation from beryllium to barium. In order to get the atomic numbers, what you need to do, you need to add इसके लिए 8, 8, 18, 18. Okay, we have that number right, 2, 8, 8, 18, 18, 32. Okay, इसके बाद 32 ऐड करेंगे. Is that clear? Okay. ठीक है. Physical nature, all of them are grayish white. All of them are, you can remember this, they are grayish white. Okay, they are harder than alkali metals. This is important. Why are they harder than alkali metals? Because you are having 2 electrons in the valence shell. If you have 2 electrons, more number of electrons, more will be the strength of the metallic bond. If greater is the strength of the metallic bond, you will be having them as hard rather than soft. Among group 1, lithium is harder and बाकी सब हम soft मानते हैं. Down the group, softness increases. इसमें भी वैसा ही होगा. Down the group, the softness is going to increase because of the decrease in metallic bond strength. Is that clear? And they are harder than alkali metals. The reason is they are having 2 electrons in their valence shell, so they will be having a stronger metallic bond. They will be diamagnetic. If they are diamagnetic, they will be colorless. They are diamagnetic because they are having NS2 configuration. They are having NS2 configuration, no unpaired electrons. If they are having ionic form, in ionic form, they will have NS0 configuration, or they have +2 oxidation states. Okay, so both in ionic as well as elemental form, they are colorless and they are diamagnetic. They have stronger metallic bond due to presence of 2 electrons in the valence shell. Down the group, atomic size increases, and in the crystal structure of them, crystal structure का मतलब ये हम solid state में पढ़ेंगे. Don't worry now. They exhibit 2 types of structures, FCC and HCP. FCC indicates face-centered cubic cell. HCP indicates hexagonal closed packing. Okay, hexagonal closed packing unit cell. You have face-centered cubic unit cell or hexagonal closed packing unit cells among these elements. We will understand what is that FCC and HCP in the chapter of solid state. No need to worry now. Okay. Okay. Melting and boiling point. Down the group, as the softness increases, the melting and boiling point are going to decrease. यहाँ पे एक exception है. Beryllium is the highest TKO, obviously. We expect barium to be least, but magnesium is the lowest. Melting and boiling point में magnesium is the lowest. That is because of no d orbitals. मतलब d orbitals के अंदर कुछ electrons नहीं है. The configuration is 1s2, 2s2, p6, 3s2. 3s2 है. There are no electrons in the d orbitals. In fact, calcium भी आपको d orbitals के अंदर electrons नहीं रहता, because it is 1s2 2s2 2p6 3s2 3p6 4s2. okay, उसमें भी आपको d orbitals के अंदर electrons नहीं है. बाद वाले elements के लिए d orbitals के अंदर electrons है. Just remember this as an exception. The reason इतना clarity नहीं है because it is not under scope. इतना mark करो, magnesium has the lowest melting and boiling point because of no electrons in the d orbitals. okay, ठीक है. Ionization energy down the group it decreases, and these elements cannot show photoelectric effect using visible light. This is an important point you need to remember. ये जो S block elements में group 1 elements जो है, group 1 elements सोडियम से start हो जाएगा. They can show photoelectric effect even with the visible light. उसके अंदर जो भी energy है that is sufficient to excite the electrons or remove the electrons, and they can show photoelectric effect. Group 2 elements, as their ionization energy is relatively more, they cannot show photoelectric effect with visible light. Is that clear? Okay. इसको कैसे याद रखना है? Sometimes this information may be given in the question. From the information you need to derive that particular element will be from group 2. क्योंकि group 1, group 2 both of them are metallic, but if they are giving a statement it doesn't show photoelectric effect with visible light, I can conclude that a particular element has to be from group 2. okay, ठीक है. Oxidation state will be showing +2 oxidation state. Down the group, the electropositive nature increases. Beryllium is least electropositive. Most of the compounds of lithium are having covalent nature. Similarly, beryllium having high polarizing power, it also has covalent nature. Okay, is that clear? ठीक. Electropositive or metallic character down the group, it increases. Density, again, there are some exceptions in the density here. Differ due to difference in the crystal structure, because different things are have. This is called as crystal structure. कुछ FCC है, कुछ HCP है. As a result, the density is going to be different. It is not a regular trend. And वहाँ पे हमने group 1 elements में ऐसा कुछ देखा. Down the group, density in general increases. Potassium का थोड़ा कम हो जाता है सोडियम से because of its greater volume. इस केस में there is a very high variation. Calcium is less than magnesium. Magnesium is less than beryllium. बेरिलियम फिर से लेस देन स्ट्रोंशियम और बेरियम, वैसा कुछ है. ओके, और एल्स बेरिलियम जो है, वी एक्सपेक्ट व्हाट इज द एक्सपेक्टेड ऑर्डर? डाउन द ग्रुप इंक्रीज होना चाहिए ना डेंसिटी. एक्सपेक्टेड इज बेरिलियम हैज टू बी लेस देन, मैग्नीशियम हैज टू बी लेस देन, ओके, लेस देन, कैल्शियम हैज टू बी लेस देन स्ट्रोंशियम और बेरियम. बट यहाँ पे क्या हुआ? कैल्शियम सबसे कम हो गया. ओके, उसके बाद कैल्शियम के प्लेस में बेरिलियम चला गया. ओके, दैट इज बिकॉज ऑफ देयर क्रिस्टल स्ट्रक्चर्स. एफसीसी में पैकिंग अलग से होता है. एज अ रिजल्ट द डेंसिटी इज गोइंग टू बी डिफरेंट. एचसी में पैकिंग अलग से होगा. वी विल अंडरस्टैंड दैट पैकिंग इन द चैप्टर ऑफ सॉलिड स्टेट. ओके, दिस particular order is not so important. Even if you don't remember this order, it's fine. Okay, conductivity, they are good conductors. And as you are having a more number of electrons in the valence shell, they will be a better conductor when compared to group 1. Group 1 are lesser when compared to group 2. Okay. Flame coloration. Flame coloration may important. Beryllium and magnesium are not showing any color. That is because of their higher ionization energies. Okay, or else उनका excitation energy ज़्यादा रहेगा. मतलब क्या है? They won't be absorbing any of the wavelengths in the VIBGYOR. If they're absorbing some wavelengths in the VIBGYOR, they can show color. If they don't absorb any of the wavelengths, they won't be showing any color. In case of group 1, lithium will show crimson red, sodium will show golden yellow, potassium shows pale violet, rubidium red violet, and cesium is violet. इस केस में beryllium और magnesium they don't show any flame coloration because of their higher excitation energies. Why do they have higher excitation energy? Because they have greater ionization energies. Okay, okay. Or else you can also say S के अंदर वाला इलेक्ट्रॉन को निकाल रहा हूँ, which is NS2 configuration, which is filled. सो आयनेशन एनर्जी ज्यादा रहता है उसका. एग्रीड? ओके. कैल्शियम शो brick red, dark red and apple green. Calcium is showing brick red. Reason red मतलब उसका complementary color आप लोग देखो. It is absorbing a lesser wavelength when compared to barium. Okay, you can just same explanation as the top group 1 elements. Just remember the colors: brick red, dark red, and barium is apple green. The colors are very very important. Flame test के colors important है. Hydration energy down the group decreases. It decreases as charge density decreases, right? As charge density decreases. Complex formation due to small size of cations and high charge density, only beryllium and magnesium can form complex. वहां पे हमने लिथियम तो कॉम्प्लेक्स बनाने की टेंडेंसी ज्यादा है और बाकी सब भी कॉम्प्लेक्सेस बना लेंगे करके कहा. यहाँ पे we will be forming complexes only with beryllium as well as magnesium, and magnesium forms a complex and it is present in chlorophyll. Okay, chlorophyll is nothing but a complex along with magnesium. Important है. chlorophyll के अंदर कौन सा metal रहता है करके पूछते हैं. Maybe NEET students can answer that very easily, but for JEE students you need to remember this. chlorophyll के अंदर आपको magnesium रहता है. Okay, a complex of magnesium is present. Next, reducing property. Down the group it increases. यहाँ पे we don't have or we won't be discussing a separate order in free state as well as in aqueous state. एक ही order है हमारे पास, दोनों में same ही है. In case of group 1 elements, lithium is having exceptionally high reducing nature in aqueous state because of its high hydration energy. Okay, यहाँ पे there is no difference between the free state as well as aqueous state. यहाँ पे जो भी ऑर्डर लिखा है aqueous state का ही लिखा है, where barium is greater than barium, strontium, calcium, magnesium, beryllium. Okay, aqueous state में ये रहा तो free state में भी यही रहेगा ना. Okay, aqueous state में हम lithium का exception क्यों लिखा? It is based on hydration. अभी aqueous state में beryllium का भी hydration ज्यादा रहता है, but वो hydration ज्यादा होने की वजह से उसका reducing nature तो ज्यादा नहीं हुआ. देखो यहाँ पे, this is the same order that is given in group 1 also. Lithium is greater than potassium, potassium is greater than barium, strontium, calcium, sodium, magnesium, and then beryllium. Which is the strongest reducing agent in S block? It is lithium. Which is the weakest reducing agent in S block? It is beryllium. Okay. Strong reducing agent in S block. Weakest reducing agent in S block. Okay, remember this. Is that clear? Okay, reactivity. They are less reactive than alkali metals because of their high ionization energies. Beryllium, it is not even showing reaction with steam. वहां पे lithium के साथ it used to show the reaction with water and the two with steam, and even then the reaction is slow. यहाँ पे beryllium के साथ it is not reacting even with steam. Okay, magnesium, it is reacting with hot water. Down the group as reactivity increases, these are able to react with cold water. Is that clear? Everyone?
Yes.
Okay. Reaction with air. In case of group 1, only lithium is able to form nitride, but group that is because of the diagonal relationship with magnesium. अभी एक group 2 elements में all of them can form nitride as well as oxide. Okay, यहाँ पे except beryllium, others are easily tarnished due to the formation of oxide layer. Beryllium being least reactive, it is having lesser tendency for the reaction with oxygen. Okay, बाकी सब क्या है? It is reacting with air and they are easily forming oxide as well as nitride. Everything we can form nitride. वहां पे only lithium is able to form nitride. Is that clear? ओके ठीक है, we will continue from this particular part. यहाँ से important है, we will continue from the reaction of with O2. यहाँ पे in general reaction लिखा है, reaction with air, उसी में specific reactions reaction with O2 देखेंगे in the next lecture. Okay, यहाँ पे ये याद रखना, everything can form a nitride. All alkaline earth metals, all group 2 elements form nitrides. लिथियम नाइट्राइड को पानी में मिलाने से क्या मिलेगा? What will I get dissolving lithium nitride in water? उसका हाइड्रोलिसिस होके lithium nitride, lithium compounds are covalent compounds. If they are covalent compounds, water में put करते ही उनका हाइड्रोलिसिस होगा. Okay, they will be broken with the help of water. उनका हाइड्रोलिसिस होके you will be forming lithium hydroxide and NH3. Similarly, magnesium nitride को भी पानी में मिलाने से NH3 मिलेगा. It is the diagonal relationship property of lithium and magnesium, na? Remember? Is that clear?
Yes, sir.
Okay. Okay. We will continue in next lecture, tomorrow's lecture. Tomorrow we will have the lecture again online. We will have it in the morning. 9 बजे start करता हूँ, ठीक है?